Hi, my name is Daniel Menacho, and this is the last project where I participate. The title of the project is Multi-Camera Acquisition System for the Virtual Model Generation with Underwater Photogrammetry. This research project was exhibited in the Ocean Conference and Exposition in 2021, and now we are waiting for the publication of the paper in IEE Ocean Engineering Society. The importance of this project is preserve the underwater environment by building 3D model. We want to develop virtual tourings with using the virtual reality glasses. We want to create awareness to protect this kind of environment in our country, like a coral reef in Paracas. Objective. And one objective is develop a low-cost and high-performance tool for the acquisition of underwater images that are intended to generate virtual tours. And another is develop and improve a photogrammetry methodology to build a 3D modeling underwater environments. Well, I participated in both objectives, but in the first, for example, I tested some electronic devices and support to build the tool. And the another, I'm more related to the underwater photogrammetry. According to the state of the art and some bibliography, I propose this methodology but, to create a photogrammetry model. We beginning with the underwater videos and the water photos, but the problem of the underwater video, when we extract photo by photo or frame by frame, we lose the blur effect because the video is an illusion of the movement. For the photogrammetry, we need clear photos. The idea of the photogrammetry is to extract some important points, shapes, or forms for each photos. With these important shapes, we can align these photos and then create the dense point cloud. With these points in the space, for example, we choose 3 points and then join 3 points, we can create a surface. And with this, we have the mesh model. And the final, to render this, we have the texture model. We have some problems. I propose some solution about that. For example, the acoustics. The acoustics happen when you take photos in the shallow depths. The solution is move the Instagram, or take photos in greater depth. And another problem is the fish air effect, and that happens because always we use a hemispherical dome to protect the camera, and the solution is use a MATLAB tool because this is a composition function. The MATLAB tool calculates all the parameters, and then you put the input, the fire effect, and the result is a flat photo. And the MATLAB tool create the inverse process. And another is the backscattering. And backscattering happens because the sea water is about 800 times dense to the air. So to reduce the backscattering, when we have artificial light source, you can take the photo near to the subject or put the light sources the most far to the camera. For example, another problem was the color channel. And this is too interesting because we have 3 photos about each channel, and the red channel have the most details about the shapes, and the blue and the green have the blur effect. The concluding about this problem is the blue and the RGB has the same performance, and the red channel has the best number of faces and number of vertices. And these 2 parameters is too important when we build the 3D model. Another experiment I did was when we know the reference. For example, I know the reference of the distance, the 0.1 and 0.2 in the Rubik cubic. I want to the software calculate another distance, but I make some mistakes in this experiment. However, some researcher, according to the root mean square, the red channel has the less error when we have some reference distance. And this is some examples of the 3D model I created. And this is some virtual tourists that we hope to have in the future with this project. And this is the bibliography, and thanks for the opportunity, and thanks for all.